And that will be 49. .349. Okay, let's see if we get PowerPoint. Remember I showed you this one last week. It's the same principles. And so you could practice it. I think the most crucial. Oh. Hold on. I have to get out of the clipboard. Sorry. Wait. This one. All right. Remember this one is the same principle. Everybody looking at my screen, the PowerPoint now? Somebody say yes. Hello?
Yeah, we're seeing it.
Right. So remember I gave you that one, you have that one. You could reinforce yourself again. In this case, it was calculated the flow pass through an 8-inch pipe and the velocity was 3 feet a second. Remember the magic formula? Basic, important formula, Q is equal to VA. Q is equal to VA. The flow is equal to the velocity by the air cross-sectional area. And then you will add for me because you learn the diameter and you learn the area just by sticking in, because they give you the 3.147 divided by 4 squared. That was 0.7 and so on and so forth. So you ended up with an area and we're working in unison. They gave me my velocity in cubic feet per second. So my area had to be in square feet. All right. Don't worry too much about pi. Pi was a man, a bright fella. 3.14. And when we multiply with V by VA is 3 feet per second by 0.349. And that gave us that. But you got cubic feet to the second, per second, sorry. And we wanted to answer in gallons a minute. And we had to remember that 1 cubic foot was 7.48 gallons. So it's 1.046 cubic feet per second by 7.48 gallons per cubic foot. And the cubic feet will go, so we end up with 7.8 gallons a second. But we have to remember that you have in 1 minute, you have 60 seconds. So you multiply that 7.829 gallons a second by 60 seconds for every minute. The seconds will go and we get the answer in GPM. Okay? Review the conversion boxes. You have to remember your conversions. You all have all that already. We went through that the first time. I give you some useful conversions so that you could have. And I think that is what I wanted to deliberate for today. Now we have a lot of work to do in respect to the issue of the gallons a minute and the flow in pipes and so on. Now, if you ask one last issue, we're doing these applications. If I was to click that off and go back to a shared screen, and I'm going back on the whiteboard, just imagine they ask me inside a pipe. You see those questions, you have to be able to think you're working with it. If they say in 20 feet of pipe, for example, and for all intents and purposes, we're talking about a circular pipe. Make life easy. A circular pipe. If they said you have the length of pipe is 10 feet, and the diameter of the pipe is 24 inches, we know that is 2 feet. You could calculate the volume of water in that pipe, right? And I gave you the conversion just now, right? Remember that piece of pipe now looking something like this. that piece of pipe looking something like this, is really a cylinder. And the length would represent your height in your formula. Remember the volume of a cylinder, pi r squared by h. And I translate that here. That is the same as the area of a circle, which is 0.78. Somebody give me a 78 what? 785 by the diameter to be squared by the height. In this case is the length of the pipe. You could say L if you want, or H. So you could, if they give you that, you could calculate the volume of water inside there, right? Here would be 0.785. The diameter is 2 by 2. D squared multiplied by 2 multiplied by 2. And the length was 10 feet. And it's feet squared by feet here. So all would be in cubic feet or feet to the cube, which is the same thing. And when you get that, all you have to remember is that 1 cubic foot is equal to 7.48 gallons. So you could calculate how much water in a 24-inch pipe, 10 feet of pipe, you could calculate the volume of water inside there. And that's how the problems, that's the kind of problems they will give you, how you apply these formulas that they will give you and the practical common sense with the knowledge on the ground. So you have to, if they tell you it's a 10-inch pipe, it's a circular pipe, and they give you a length, one time, in that 10 feet of pipe, you have to view it as a cylinder. So the equation you have to apply is that volume of a cylinder. Pressing on into the book, we will have some more shapes, tanks that are similar, circular, not circular, but spherical maybe. You have some strange tank and someone on a piece looking as a rectangle and the top being a circular. We'll do some of that. I want to post some of that for you all so you could go. So in that case, if it's too strange, if pieces are cylinder and pieces are circle, strange like a tank, you know you'll have to divide. To find the volume, you'll have to do the piece first as a cylinder, then to do this piece as a sphere, and that's where the equation of the sphere would come in. All right? So any doubts, any questions? It's 11:45. I promise between what I wanted to do and your questions and to go back on the problems, we'll go up to 11:45. I know you're getting tired now, but I'm open to any question. No questions? I'm not sure if you're hearing me. Somebody say they're hearing me. Eh? We hearing me?
One question. Anybody can get 100% in your class?
Anybody can get?
100% in your class?
Yeah.
Okay, cool. Just checking.
Don't worry, man. I don't back so hard, especially when you make a good effort. Now, I will endeavor now to, first of all, let me tell you, those who want to send back, please send back the, again, I said there are 1 or 2 persons who duplicated the page 2. They sent me page 1 twice of the sheet number 2. They have some people who didn't send sheet number 3 yet. Again, I said I wanted to go through some of the scientific notation. And sheet number 1, Alvin is there, I've not seen him. How much of it we got? Those who didn't do sheet number 1 and those who had errors, send them again. I will grade them. While I'm sitting here, I will grade them and post them for you. What I want to do too, some of the points where, well, I use the board, so you should be writing, but there's 1 or 2 things I would reinforce, and I would write it and maybe scan it and send it on the WhatsApp. So important steps when you're working. So send module 3, those who didn't do it yet. Send over module 1 if you think you had some errors and you didn't understand, there was some misunderstanding. And I will mark them and bring you up to scratch. Remember, we have another module open.
When you say sheet number 1, which one are you talking about? Because
that's the one with scientific notation.
Because the quiz one was multiple choice.
Yeah, scientific notation. That's the one with most of it was scientific notation. Right? I think some people didn't get onto that. I didn't know if you do it. You could send it to me again and have a look. Sheet 3 is the one with the averages. As a matter of fact, I worked the 3 problems out as part of your work for you. Aside, I find it was incumbent on me to really work them. Some people was having, although average is straightforward, but some people was having some issues. And you saw the numbers repeat, 102 repeated twice, but you have to add it. Is that don't add it once. It's there. It happened. It happened. For example, if it's the volumes in a tank, one day you get 102, the next day you get the same 102. So that's 102 plus 102 plus the rest, and you have to add it as an event or a number or a day or so. All right? Some people left it out. They add 102 once. You don't do that. If it's repeating, you add it in. All right? And you count it as one of the numbers. Anything else? Keep practicing. That's why I use the board so much today. I mean, you don't put up that in a PowerPoint and just put it there. You have to practice on the steps. And the calculator is very bright already, but the calculator doesn't give you the steps. You have to show your steps, walk your steps down, get your dimension analysis correct. Then finally, when you want to work out something like this down here, you use your calculator. So with that, I want to rest my keys for today. As I say, if you don't have any doubts, I think we could rest for today. I ain't hearing anything, so if you want to go on, we could go on, you know. We're home anyway. Ja, are you there?
Yes, I am.
Yeah, I see people don't want to log in. They want a reason to stay away from coronavirus. People don't want to log out.
Well, good for them. while they can make the best of having you with them, that's great.
Yeah. Yeah, I think one thing I want to tell you again, you will meet that little maths in all the way down to judgment in most questions. Yes, when you meet the regs and regulation and so on, but when you come to dosing and calculating and concentration and whatever, you'll have to do the little maths. I don't know anybody who could pass the exam and certify without the maths base and getting hang of the maths. I don't know who could do that. So I just want to remind you of that. You have some time inside now. When you're on the plant, when you're locked down, when you go on the plant, be vigilant, but do some work until the worst is over. Okay? So have a good one. And look for some grades. I'll be logging. Upload your stuff. If you have any doubt, upload it to. I'll attend to it. Click on and respond to you. Some of it, if it's straightforward, I'll do it on the WhatsApp. Okay? So have a good one for now.
Yeah, well, everybody keep safe. Really good classes, and
Yeah.
I see that people are very attentive and thoroughly enjoying it. I like the participation. All good. And keep safe. And remember, you guys are the ones who are keeping, in all of this chaos,
Yep.
water operators, water is life. You're the ones who do the right things to keep people alive.
Yeah.
So keep on doing what you're doing. All the
Yep.
best.
Now they would understand what matters most. Water. Safe drinking water. They say wash your hands, Boy, if there was no water, we couldn't wash our hands. The whole planet will die.
Definitely.
Yep. So next time, all the best.
Yes.
And keep on doing the good work. I was impressed, as I said, with the sheet 2. Thank you. I'm out now.